We have like 5 APIs.
All right, John, you're up.
Yeah.
Okay. Yeah, should I stand in front of
That's
you?
what I thought. We were doing it in front of the camera.
Yep.
Okay.
All right, we're gonna get started. Thanks
Right.
for coming. I have a mic. Can you hear me now?
No, it's not.
It's not?
No, it's not gonna do over. That's
Oh,
just
that's
for
for
that.
Oh,
Okay.
We don't need to hear.
Nah,
We
we
just
just
need
need
some-
to.
We have another mic, you wanna use that?
We don't need me on a mic.
All right.
All right, well, thanks for attending our next API meetup, API Security Meetup. This one, we're gonna talk about gateway segmentation. Segmenting your gateways is another security approach that you can take. And so we have Robert Buchanan here tonight to talk about that. But before we get going, we'd like to do a few housekeeping things. One is for attending tonight, if you are interested in going to the Momentum Conference, we have a discount code for you. The Momentum Conference is a local conference here, and the discount code is APISEC, API SEC. So if you're going there and want to use that discount code, you heard it here first. And then as another housekeeping item, we'll bring Leslie up here to give a little bit of pitch for Engage. Engage is who is sponsoring this API meetup, providing the refreshments and the location and everything else. And so to talk a little bit about Engage, Leslie.
Thank you, John. I'm not talking a lot or really pitching. I'm just telling you who Engage is. We're a purpose-driven technology consulting company. We design, build, and deliver software solutions. And we are very much into giving back into the community. We like to do that by hosting things like this and hosting other meetups like C3. So we want to give a little shout out for that. Is it okay if I just segue into that? Brandon, you want to mention a little bit about C3?
Yeah, C3 happens next week, this month. It's the third Wednesday of the month. We are a group of developers who come together to practice our craft. It is all about coming together and learning to pair and practice with code katas. So it's a good way to meet new people, get introduced. We have a lot of boot camp attendees and graduates, so it's a good way to share knowledge and experience as well.
And then you said there's another meetup?
Yep.
Okay.
You want Sorry, that was
But you're gonna
really
introduce
smooth.
me.
But thank you everybody for coming. You know to help yourself to everything back there. And he has another.
So, has anyone here heard of Southwest Ohio Gift Camp? All right. Do you have a good time at Southwest Ohio Gift Camp?
Yeah.
All right. So basically, this will be our 13th year, but we have, it's basically a code camp or a hackathon, but it's for nonprofits. So this year we're going to have 5 nonprofits where we just do tech stuff over the weekend for the nonprofits. So I'll just be honest, most of it's website built because these nonprofits have nothing, and so they come to us, and then we have smart people, we get them together, and then basically help them over that weekend to get something stood up. So by the end of the weekend, they have at least something they can go forward with. And so that is October 11th through the 13th at the VOA Learning Center up in Miami, which is right off of 75.
Who supports it?
Who supports
After
it?
it's done.
What's that?
Who supports it after it's done? Unless you have this thing.
That is up to them.
Okay.
And maybe the kindness of the team. But one of the things we say at Gift Camp is what happens at Gift Camp stays at Gift Camp. Meaning you can give that weekend, and you have no obligation to stay. Now, if you have the kindness of your heart, you want to keep giving to that nonprofit, then you can. But there's no obligation after that. So it's really just to get these nonprofits bootstrapped. So we've done it 13 years. We've probably helped about 50 nonprofits over those years. And
Hey, Matt, I think it's 15 this year.
is it 15 this year?
That's what they were talking about the other night for.
Okay,
ordering-
15 this year. Yeah.
That's awesome.
All right.
That's a lot.
Huh?
That's a lot.
Okay. All right. Anyway, so just check it out, southwestohiogiftcamp.org if you want more information.
Awesome. Thanks, Matt. That's very cool. All right. Without further ado, we'll get to our topic at hand and Mr. Robert Buchanan.
All right. How's it going, all? Today we're going to talk about API gateway segmentation. A lot of times companies really think about API gateways as a barrier or a funnel for the entry point they don't think about all the other ways that you can use API gateways, such as internally and environment-based as well as others. So we're going to cover a lot of those topics, and we're going to first start, though, making sure everyone has a level playing field. Talk about, one, who am I? I am a programmer, software carpenter, an architect, and an author. I published a book on Kong, Becoming the King of API Gateways, which we do have some Kong representation in the crowd. But I am an architect over at Procter & Gamble, previously Kroger. So I have a lot of experience dealing with, larger volume systems and distributed systems across multiple clouds. I will have a disclaimer saying all these thoughts and opinions and actions are based on me and my professional experience, not based on the opinions of my employer, current, past, or present, or future. So these are all my opinions. Don't hold them accountable. All right, so let's get an overview of what is a gateway. We're going to breeze through this unless I see people really questioning what I'm asking.
I have a question.
Yeah.
Who took that lovely portrait of you in
Oh, I don't know, some random guy. No, John did take that lovely portrait of me many years ago. I need to get an updated one. But in API Gateway, we're going to cover the basics, brief terminology baseline, and then we're going to talk about the 3 Ps of APIs. First off, what is a gateway? A lot of people see it as a single entry point, kind of like your funnel from the outside to the inside. A lot of people focus on the north to south traffic, really external to internal traffic. A lot of what it does is it's really a glorified reverse proxy. We've heard of Nginx, we've heard of Apache. At the end of the day, we took those ideologies of how to route traffic with that system and said, let's put a security layer on here. Let's do some request processing. So it became a more intelligent reverse proxy, and that's what we call an API gateway these days. The key benefits are request routing and load balancing, security, and then ultimately analytics, which drives us to making business decisions based on consumption. So the key functions, again, with the analytics that we get from API gateways by giving everything through a funnel, we're able to make key business decisions on where we need to, one, protect us better, because the more traffic one API is getting, the more risk it has to the company, but also the more traffic an API gets, the more valuable it is from a reuse perspective as a cost avoidance, or it means that it's a very popular API, you can start charging for it, and then that brings in alternate revenue. You have the added security layer because it's acting as a policy enforcement point, to where, and actually can act as a policy decision point too. It really depends on how you architect it, but either side of those, when you're dealing with policy, the API gateways are helping you stop things like the Log4j attacks that happened a couple years ago, or the basic OWASP stuff that is making sure people aren't, doing BOFLA or BIFLA, the 2 top OWASP ones where, they're trying to get access to things that they don't have access to by, tricking the system or trying to fake out the system. You also stop things like SQL injection. There's, bot detection in some cases. You can do a lot of different security policies there. The other thing you can do is, because you have the analytics of the traffic coming in, you have security policy enforcement, and then you have request routing, you start building threat analytics. And those threat analytics really give you a stronger posture to understand where people are coming from and attacking you from. North Korea likes to attack a lot of people. It's a lot of fun. You'll see them up in logs all the time, and you're like, why?
Yeah. That point is going down.
At my previous employer at Kroger, we saw North Korea hit us a few times. We're like, what are you going to do? Like, come on, guys. All right, topic baseline, or, let's talk about some baseline terminology. Because we talked about internal and external in this topic, we're going to define those, because I've learned over the decade of APIs, they mean different things to different people. So we're going to talk about internal meaning anything that is reachable from within the company's network. So anything that is owned by the company, anything that is routable within the company's network, it is not meant to be touched from the outside. External is anything that is touchable from the outside. Doesn't mean that it's meant to be used by the outside, doesn't mean that it is, but if it has an IP address that anybody can hit from the external network, the World Wide Web, it's considered external. And then you have the key modifier, published, meaning it's published for consumption based on an audience. You'll have internally published, you'll have externally published, you'll have different combinations of published, so that you know what audience is actually meant to consume it, which gives you some idea of how to craft your security or your segmentation. which gets us into the 3 Ps of APIs. There's really 3 different main personas. These do break off into sub-personas and sub-different areas, but you have public, partner, and private. Public is general availability. Anybody on the internet can hit it, anybody on the internet can discover it, use it, consume it. There may be a login screen, there may be an OAuth2 account that they have to register, but ultimately, anybody in the world can access it. Then you have partner. This is where you get more strategic. This is where you start charging people for, bulk requests, or you have a strategic partnership with a retailer or another company, and you start exchanging data. Those are APIs that may not be, robust to handle the onslaught of the general public traffic. They may be designed slightly different to accomplish a goal that both parties kind of agree to. These are more based on strategic outcomes. And then you have the private side, which is meant for the company who is building them and only for the company who is building them. These are where a lot of people have the misnomer of, oh, it's behind the Great Firewall, it's safe. It's not safe. Protect your APIs. So that brings us to, why does segmentation matter? So with segmentation, we're going to cover a few topics: granular traffic control, enhanced security posture, scalability and performance, and management and monitoring. So when we talk about gateway segmentation, we are talking about the idea of really positioning an API gateway in front of your APIs themselves, and to make it really important and work within a large enterprise or even a small company, you have to understand where your traffic's coming from, how your traffic's being used, and what you're really trying to give your security posture on. A lot of folks, tend to not think about an internal gateway to control the east and west traffic. This is, API A talking to API B inside your network, inside your internal network. It's all you. It's safe, right? 40 to 50% of breaches are internal actors. Lapsus during COVID bought credentials to AT&T for $20,000. They got in and did some bad things. So internal actors are also malicious, and either ignorance or negligence or selling off their credentials. We should not trust internal traffic. You can trust but verify. You can do slightly less rigor on them, but you should definitely always do some rigor to make sure east and west does not happen freely. Then you also have the external side, the north and south, coming from the World Wide Web to the internal network, crossing that boundary. You want to make sure that you have those kind of wired in and really segmented off to make sure you're protecting that lens. Then when you get into talking about more of the segmentation case studies, which we'll talk about these patterns later, but you really start analyzing your SLAs, your different personas. Do you really want to mix your public APIs running through a gateway on your private API gateway and really mixing that context? Some companies, yes, it works. Some companies like, no, we're going to take the traditional separation of concerns. It also changes how much you care about the public side going down, which may only get 10 requests per minute or 10,000 requests a minute. It's not that big of a deal, just as a way to show people you're doing APIs, where your private one is making you millions of dollars that you can't have it go down. So it really depends on when and why you want to segment there. But it gives you more granular control over your traffic if you decide to segment. And then there's the geographic segmentation. Let's be real, it sucks going from California to an East Coast server to get down to an application. Why not deploy that application in 2 places? Or the worst that I've seen is actually a company to where the call would come in to their central server from the West Coast, would hit East Coast, and then it would say, oh, that's available on the West Coast, and then go back to West Coast to get the data to come back and go forward. They're adding seconds on the request call versus just standing up another API gateway and getting a proper load balancer in front of those gateways. And then you also have the compliance and regulatory traffic. You don't want to mix your PCI traffic with your non-PCI traffic. Credit card traffic is awful. Make sure you segment that. You don't want to mix your HIPAA data with your non-HIPAA data. That's also bad. So there's another segmentation that you start talking about. Now, with all these segmentations, when we talk about management and monitoring it, it doesn't mean that you're out on the land with 20 different gateway instances you can't manage, because you can actually end up building a gateway agnostic way to do your policies to make sure that as you're doing policies and as you're doing that enforcement, you control it centrally and federate those policies out. So With gateway segmentation, you get enhanced security posture. You can reduce your attack surfaces. If you're protecting your private gateway or your private internal endpoints, you can do some rigor there. You can ensure that you're using MTLS, you're doing shared secrets, or something to elevate to make sure that you're not getting foreign traffic. You can then, on your public side, you can say, hey, we don't let you do gets, or we only let you do gets, we don't let you do deletes. Instantly, you've eliminated an attack vector. It can't process it. So there's a lot of ways that you can really enhance that security posture just by scoping what this gateway is for. Fine-tuned access control, same thing internally. You may accept any token that validates against the token minter that you have inside your company, like an Okta or a Janran or something along those lines. But for the public gateway, you may say, it only works if you have this and an audience, or this and a scope, or your token is valid for 5 minutes or less. Internally, they could be valid for hours. You have different scopes there, different policies. And then you also have compliance and data sovereignty. That's a fun one that's coming up a lot, is data sovereignty. If you work anything in the EU or in other countries, you really get into a fun pickle of different rules for different countries, where you have to either write to the country of origin. So like I believe Ireland, you have to write the data in Ireland, but then you can copy it out of there. In Russia, you have to write to Russia before you have to write first in Russia, then you can transfer. Some countries are like, nope, it writes there and stays there. Can't move it. So you start thinking about, all those interactions and where you have to put APIs based on the countries you're dealing with. You may have to put a gateway solely for that, just to route within that network or within that region. And then you get the scalability and performance when you talk about segmentation. If you can take your 10,000 clients and split it up amongst 3 different segments, well, now you're only dealing with 3,300 clients per gateway, potentially. You also have more flexibility on how you do the segmentation that meets your demands as a company. So the more that you do geographic-based APIs or geographic-based systems, you can start leveraging where to horizontally scale or vertically scale those servers to make sure that you handle the traffic where it's hot. There's actually a really cool project that did not get off the ground out of, I want to say it's Cornell, but it was SuperCloud, to where they actually found a way to migrate systems from cloud to cloud without losing connections live, using a lot of VMware sharding and all kinds of stuff, and gave me an idea of like, let's build a gateway that constantly moves based on traffic. Move it from region to region automatically. So, but there are some interesting plays in the cloud that you can do scaling in different ways. So when that comes to management, you're like, well, we have all these segmentations, and we're going to end up having multiple gateways, potentially even different gateway technology. How do I do the management of it, the monitoring of it, and the logging of it? Well, you can do isolated management. If you want your PCI folks to manage the PCI side, you want your HIPAA folks to handle HIPAA, that totally works. That is a play that you can do. Now, as long as that team is upskilled on how API gateways work and the attack vectors of API gateways and the threat volume that they're going to receive, then great. Have multiple teams run gateways. 9 times out of 10, I've seen companies look at going, we don't want to teach a lot of people gateways. That's a lot of expensive talent to keep managing gateways. So let's move it to one team. Well, when you have that one team, you have to start thinking about how to make a federated policy manager to where you can push out the same policy to the many different gateway systems you have, or the many different installations of gateways, without making it a tedious event. You could do this by building custom software. You could do it by choosing a gateway that is GitOps oriented or Terraform oriented. You can kind of distribute that way, or by buying a gateway that natively supports this type of architecture. But ultimately, you're not left out in the dust. There are many ways to solve a centrally managed policy engine with federated instances of gateways, as well as just doing federated management of the gateways. That also works. So when we talk about policy management and logging, in a sense, is the same way. Is, when we talk about logging, much like the different groups handling the HIPAA or the PCI, we really want to look at, does the team that's managing the non-HIPAA, non-PCI gateway really need to see the HIPAA traffic or the HIPAA logs or the monitoring of it? Maybe not. If you can really have the multiple teams, that gives you a lot of benefit of separating that knowledge set or separating the data classifications. But when you do get it as all one team, that team really needs to augment those logs or make sure they understand where that log entry is coming from and how that log entry will be affected depending on the environment or the segment that it's in. So when you do talk about segmentation, make sure policy management and your monitoring and logging are at the forefront of your decisions. Because without those two things, you're not going to have a successful gateway. And then ultimately, with managing multiple segments or segmented API gateways, you get granular SLA. I can have a slower SLA on my public endpoints if I'm not charging them money, but if I'm charging them money for SOX compliance and other things, I better have a really good or really high SLA. Where internally, I need a really high SLA to make sure my business is running, but not necessarily, I can balance those actions out based on scale, based on, policies that are being enforced and so forth. So, different segmentation patterns. Can anyone guess the different ways that you can segment? Let's see what we can get from the crowd. What is a way that you can segment gateways? I've mentioned several in this talk already. What do we have?
Based on the cloud provider or on-prem?
Cloud provider or on-prem, yep. Geographically, yep. Regulatory.
By environment?
By environment. There we go. Data classification. I think I have three more. One of them is actually one I did not cover.
Inbound, outbound.
Internal, external versus those, yep. One thing that we did not talk about yet so far is what about client-based? What if I have a high-profile client that is spending $10 million with us and I want to make sure they're happy? I'm going to segment them off. So we're going to cover segmentation patterns of purpose-based, environment-based, geography-based, service-oriented, client-specific, tiered-based, by sensitivity, as well as by business domain. So we'll cover some benefits, and then we'll get into a use case right after this. So environment-based, we do have folks who separate their production from development, from staging. Personally, I like to look at non-prod and prod. I think the 10 other environments that are not production is kind of redundant overall, that you should be able to develop locally, test locally, push to a non-prod, test it there, and then move it to production. But the industry begs to differ on that one. But the use case is having isolated environments to ensure that your tests don't interfere with a live going traffic or, and also applying different security levels, because in a non-prod environment, you may not care that all security, actions are hit. But I would say that's usually where you end up getting too lax on non-prod, because then people will find a way to breach that, and when they breach that, they breach your internal network. That internal network is somehow connected to prod 9 times out of 10. So I would always go with the adage of treat your API, regardless if it's development or production, treat it as if it is publicly available at all times, because it's not a matter of if it's publicly available, it's a matter of when. Because when someone breaches it, when someone finds it, when someone pokes a hole in it, that will become public. But with environment-based, you do prevent cross-environment contamination. You do enable safe experimentation so that you don't take down production, as well as different SLAs and traffic handling based on those environments. You do get a lot of leeway in environment-based systems to where you can play with like service virtualization, mocking, mock servers. You can even play with different policies to, augment your logs, or, even just trim your logs where, hey, non-prod, I don't need 20 terabytes of log data a day. I need like a gig, and I only care about these messages. So if you're going to do environment-based patterns, this is a decent approach to make sure that you have, everything playing, as you need to. The biggest thing I would suggest is if you only do 2 environments, that non-prod mimics production outside of who's consuming it. If you do multiple environments that are lower, such as development and staging, make one of the environments kind of more of a Wild West in a sense, because that's going to make your developers happy, but then make sure that it's a segmented network that they can't breach the rest of the company. But you kind of have to have tiering with your developers, or you're just going to make them mad. Let's be real. If developers have to go through all the rigor for a POC to get onto a gateway as they do for production, they're just going to go to production. So, purpose-based, you can do a public one versus internal. You can do consumer-facing versus partner. Really, it comes down to whatever you define as your purpose of creating the segmentation. It could even be based on companies who have multiple subsidiaries, like Alphabet has Google and some other companies. DeepMind, I think, is another company. They could have 2 different gateways just for that, right? And that would be their purpose based. They could do it by a myriad of different reasons, but where it gives you the benefit is you can then start talking about, hey, this purpose doesn't need rate limiting because we know it has mitigating controls like mutual TLS and an OAuth 2 token and a signed secret that's coming across. Like, based on what your purpose is, you can actually relinquish some of the policies that you normally enforce because you have other mitigating controls or you have other standards in place that will still prevent breaches or prevent incidents in general. But separating out a partner API that shares data between business from a public API really reduces your exposure from certain attack vectors or certain business attack vectors as well. Because one of the things that came out during COVID, it's not really coined, but it does happen and it's talked about, is there's denial of service, which is just mass packets going at your gateways. But now there's also the concept of business denial of service, which is more of, hey, let me consume all your order slots for pickup on Uber Eats, and then let me cancel them all. So you have people getting refunds and people getting money from that way, or just delaying your business from processing things, right? There is a content or attack pattern of hacktivism that is going after spending businesses' money by spinning up their cloud resources by more volume, or doing manipulations that allow them to cost the company money while they reap the benefits, or they just prove a point. So even there, you can then have purpose-based gateways that say, hey, this is for this purpose, we can do these controls to prevent that type of attack. Then you have your geography-based. That one's a little more, self-explanatory on, we have to optimize latency, we have to optimize compliance, GDPR, CCPA for the different countries, US and European Union. You have the different rules across the countries of how data is stored. Doing geographic-based segmentation is really beneficial for those purposes, and also just lowering the request time, right? If I have to go from the Europe to Americas to get to, to say, hey, the gateway points me back to a server, that's a lot of latency just to make that connection and point to the right server. So this is where we need to look at, put the gateway as close to the services as you can, including even, GCP East and GCP West. Put one in each one of those. You're still within the same country, but that's far enough distance that takes a lot of overhead off your clients if you're able to route them faster. Service-oriented segmentation is more about creating it to where if you have a bunch of microservices in your ecosystem, I think Uber, in 2019 when they did a talk at API World, they had 4,000 microservices to their 40 developers. So they had a crazy number of microservices, but you'll see this a lot with Kubernetes systems where they'll put a gateway at the ingress gateway for the Kubernetes cluster, and that manages that gateway for that cluster. So you can do service-oriented gateways to where it's more along those lines of services within a cluster like Kubernetes, or even within like payment processing, where that's a service that you want to handle kind of separate off on its own. We only want payment traffic through here. Another way to look at this is even, we'll cover it in a minute, but like business domain or even architectural domain, like fulfillment gets their own gateway, order management gets their own gateway, e-commerce gets their own gateway because the traffic patterns are different. Order management may be low volume that you don't need beefy servers or redundancy across the board, but your shopping cart does because it gets hit 1,000 times a second. So you can really start playing with the segmentation there to say, we're doing this based on elasticity and stability. Then you have client specific. Again, if you have a client that's asking, paying you $10 million for API access, you might just want to stand up their own gateway because that's quite a bit of money to leave for chance for some, hacktivists to come through and blow up your gateway just because they're on it, right? With that, you also get different policies. There's a point in time when I was integrating with a company to where they did not do OAuth 2. They did something custom with a signed header. and the signed header would come in, we would have to make a call back out to validate it. So we had to write different custom policies. If we put that on every single gateway, that could potentially lead to a problem because that's a lot of overhead if it started seeing a lot more traffic on every gateway because it's firing off those checks and those extra requests. But if we built that gateway just for that client, we would understand and be able to monitor it much finely tuned for our logging side to say, hey, this process is taking way too much time. Let's refactor it, let's improve it. Because ultimately your policies is still code that you as developers write, so you still need to monitor each policy execution at the gateway level to understand how much processing time it's taking. Then you have tier-based. If you do free, premium, and enterprise, like if you're operating a SaaS company, again, your free tier may need a lot more instances, but not beefier instances because of volume of like the small level stuff. But when you start getting into enterprise tier-based systems, you may be transferring terabytes of data a second with enterprises because they're vacuuming up all the data with that relationship, where your free tier is spending 100 megs a minute. So there's different reasons of why you do it based on that scenario, and those will give you different behaviors and policies as well to really make sure you're meeting your business needs when you define how you want to segment your gateways. And by the way, you can use all these patterns all at once, or you can pick and choose which ones match and work. But I mean, there's actually reasons to do geographic tiered as well, so you can even combine them that way. Or geographic data sensitivity of saying, hey, I need to manage a PCI lane in Europe because we process credit cards there. But I also need a PCI lane in the United States because we do it there as well. So these all patterns are very interminglable. You can use them interchangeable with each other. You can combine them together to make the right business case for your API gateway management. So with this one, data sensitivity, as we said, like PCI data, HIPAA data, even critical data, like companies who have services that are transferring secret related or secret classified data, they may spin up a separate gateway just to handle that, simply because now they can lock down and do tactics like pure mutual TLS. They can do other ones where they add extra endings to the packet to ensure. Which that was an old Yahoo trick, actually. It was a security for Yahoo for a long time ago. They did, at the end of the packet, they added a bit, and if you didn't have that bit when the packet came to the receiving server, they would reject it. But it would only happen through their gateways that they would do it, so only traffic that they validated would go to the server, and anything that was malicious wouldn't know about that. So, but you can do
Until
tactics
they
like
do.
that. Huh?
Until they do.
Well, until they do. But at least, you can do different things along those lines. Shared secrets, multiple headers, combinations of data. Like you can really, for data sensitivity, segmentation, you can really crank up the creativity on how you protect it versus just OAuth 2, right? But a healthcare API is a good example. You don't want your patient records going through a general gateway that your Git endpoint for all your products goes through, right? You want it to go through a highly sensitive or one that's closely monitored in a segmented network as well, and really protect it off. Because HIPAA violations suck. They're expensive.
GovCloud, FedRAMP's another one too.
What was that?
GovCloud, FedRAMP kind of stuff.
Yep. Yeah. More of the government style workloads and whatnot, you don't want to mess with those. You want to air gap them as much as possible. Business domains, again, you can have one per business company or subsidiary, like I mentioned with Alphabet. You can have it per even group within a company. Again, HR data, if you have a heavy HR company like say Workday, you may want to have it per client and per function. They have two different functions, the general employee and then the contractor side of Vinley when they purchase that company. You may want to have a gateway per client like Kroger or Walmart or whatnot for the Workday side, but also an API gateway for their contracting side, because that data sensitivity by just tracking and monitoring where it's going in your ecosystem. So there's a lot of different reasons of why you'd want tighter controls or even looser controls on different data sets based on the domain. So let's talk into some case studies. With all that segmentation, we're going to dive into 2 case studies. I tried to find more, but funny enough, people don't publish their gateways very often. But I can talk about more different patterns that I've seen, different patterns I've consulted on. One was Netflix. They actually are very open about their gateway and how they do it. They actually open source Zool, which is their API gateway. Funny enough, it's a Java-based gateway, which actually befuddled me that it got the performance it needed, just because it's quite a bit of bloat. But hey, Netflix knows what they're doing. So this is a very simple picture of the gateway, but they actually created a system using Zool, and they dubbed it Wall-E. And what they're actually able to do with it is they originally started off with, we wanted teams to go fast, and it's covered in these 2 blog posts at the bottom. But they wanted teams to go fast, so they built a way to where teams could get up and running and be able to build their solutions quickly. But when they went to go to production, they had a laundry list of questions to ask because they had to ensure the security, they had to do this, they had to do that. Well, after working with that, developers being upset, things not really moving quickly, or things going quickly but not having the right security, they started talking amongst themselves to really come up with a way to kind of get to a centralized yet federated deployment of their gateways, multiple instances across the field. But they started to change their policies of what the gateway was handling to where they took authentication and baked it into their architecture to where their gateway will actually handle the authentication part across the different services, to where you don't have to necessarily write a Netflix app that handles authentication. You're just verifying it versus actually managing it completely. And their gateway Zool handles a lot of that capability as well as the other WAF capabilities, because they decided we're going to use one and we're going to just make many instances across the board. You spin up a Wall-E, it's centrally managed, it gets all the protection, you're good to go. And then with doing this, they definitely went down the developer engagement route of saying, when they went to the security questions from like 140 down to, are you using Wall-E or not? And if it said yes, you could be up in 10 minutes in production. If you said no, you got to the questions. Why aren't you doing it? What's going on? What are you doing? Because they put a lot of their controls into the gateways and really empowered the central gateway systems, or empowered their development teams to manage that gateway to really make sure you had the best practices, really make sure you had security through and through. I think a lot of companies tend to lean towards a centralized API gateway as one, maybe do segmentation if you're dealing with PCI and HIPAA, but really we have one team that manages it, everyone has to go through it. Where that kind of has the folly is if that team's not staffed well, if that team's not managed well, if the team is inexperienced, they become a massive bottleneck that developers use the analogy all the time. Developers like water. You put up a dam, process, a toll gate that's blocking them. They're going to poke a hole through it. They're going to go over top of it, or they're going to go around it and just do shadow IT. So we really need to look at a lot of these solutions and teams and how we really mandate and control security for things like gateways, as we need to build a product, and that product needs to be able to move that water with the right level of raising up the team to be better, with also making sure that we handle a lot of those guardrails for them. You need to have a very well established team with good community connections. They can't be seen as a hard team to work with or a difficult team to work with, because they need to be able to go to your engineering community and say, hey, we really need you to do this. I'm sorry it's a bit of work. And most teams will be like, oh, absolutely, because you made their lives easier. So the more you have really the DevRel role, or the people that are evangelizing, as well as the very in-depth security folks on your gateways, the better your company is going to manage them. Because they're going to be able to inspire the developers to do the right thing, provide the tools for them to do the right thing, and then make it really freaking easy. And if you do those, people will take security all day long. When you make it hard, they'll go around it. And then there's a large retailer case study. The large retailer did a global gateway architecture to where there was multiple regions. We had to manage those regions, and there's actually a little bit off of this that I excluded and I'll talk about. But really it came down to is they had a global gateway, a CDN provider that said, hey, when the traffic comes in, we're going to look at the path and we're going to tell you where this service actually lives. And it could shortcut it going down to an on-premise service or an on-premise gateway or a different region to realize that service is not at that region. So at the global gateway, you'd run a little bit of logic saying, hey, service A is over in Azure. Let me route you to that regional gateway because that's where my concern ends. I know that it's in Azure region, I'm gonna send you to Azure. And they could even take that regional gateway and make it Azure East, Azure West, Azure whatever, and really segment out those different regions. Once it gets to that regional gateway, it goes, hey, that app is here. Let me send you right down to that API. You're off to the races. Now, that regional gateway doesn't know about any other regions. That was kind of an optimization or a technical debt that they took on because they didn't really need service meshing at the time. A way to improve this architecture would say regional gateway in Azure knows what lives in regional gateway in GCP. That way, if there is a failover scenario or something calls the regional gateway and really needs to be in the GCP side, we can route it over and really have this mesh, this global gateway mesh. But in this scenario, they had a global gateway, does a lot of the geographical routing, sticks it into the right region. That region only cared about what was in that region and would only route to things in that region. The piece that I left off this diagram was they had commercial clients. Commercial clients required SOC 2 compliance for all their requests so that they could pay for the volume that they were receiving. So what they did is they actually used a different gateway solution that actually complied with the SOX compliance. And that allowed them to go from the global gateway over to the SOX compliance gateway and then back down to the regional gateways to where they could then route it to the right request or right location. And that allowed them to get that enhanced logging and get the enhanced analytics to comply with the regulatory side. So yes, they had gateway to gateway to gateway, but at the same time, that secured them from having any liabilities with legalities or compliance. What was that?
It seems so familiar to me.
I know, right? So familiar. So in some of the other studies, some of the other segmentation I've seen is I've even seen it to where each application, because they're doing more monolithic or modular applications, to where they'll put a gateway in front of each application and they kind of own that domain, right? So if you have a big application, and I don't know if this is their case, so I'll just use their name, but if you had something like Workday, which is a big old application, a lot of pieces moving it, they might have one sitting in front of them, and that handles all of Workday services. But, you know, like I mentioned, Vinley or some other project internally may put one in front of them because they don't want to mess with the Workday routing, the Workday logic, or the policies, but they still need their own gateway routing technology. Ultimately, when we look at API gateways, you can build one yourself. They're not magic. Don't let people tell you it's a solved problem. There's lots of different ways to interpret how you want to function with a gateway. The key thing will be is make sure when you do build one, or if you do build one, you validate the testing with security professionals. Make sure it's secure for your use case. But at the end of the day, a lot of the API gateways that have come out, they're built on top of Nginx with Lua, which is where Kong and API 6 lie. They're built in complete new engines like Trafic is all in Go, but that's moving into the API gateway space. You have Type, which is also Go. And then you have others that are like, I want to call it Zuplo, I believe is the name of it, but they're more Node.js based. And they're completely SaaS oriented, right? Ultimately, you need to choose the right gateway technology and the right way that you want to segment it. But keep in mind, you can use all the gateway technologies if you wanted, as long as you make those policies consistent and you manage them consistently. You can really make an abstraction of those policies and really send one out and say, hey, I need rate limiting on all the gateways, 100 requests per second. You can build an engine pretty quickly to say, well, we have these 5 technologies. We need to translate this, policy into these different shapes for these different gateways, fire it off and manage it. And that will give you a way to robustly, go with the flow of where the leaders point you to. Because some leaders in the companies will say, hey, we're cloud agnostic, choose open source. That's the best choice. But if not, and they say, oh, we're cloud native, choose whatever the cloud provider's doing, you get to start learning what Apigee is and the nightmares it comes with, or what Azure APIM is and the scariness that it deals with. So,
Don't mention AWS either.
AWS, it's a whole different beast, but that one's coming up less and less because a lot of large retailers are forcing people off of AWS.
Yeah.
So, and a lot of companies are pulling weight saying, they're competing with us, let's not use them. And you're not allowed to use them either. So it gets real interesting. Questions? It's a lot of topic. Yes.
So when we have so many gateways like this based on segmentation, right?
Yep.
There's one gateway for PCA, one for PHA, one for non-PCA and PHA, and based on environment, Azure, GCP. I mean, how do we manage if we have 20 gateways like that, or 20, 30 gateways like that? What is the efficient way to manage these many costs? They would differ in terms of configuration, right? I mean, you
Right.
can't keep all these gateways exactly the same configuration. What's the efficient way to sort of manage this?
I would say that you can keep them mostly the same, right? From infrastructure perspective, unless you're forced into certain technologies because of cloud providers, that's when it goes away. But if you have the option of open source, you could choose the same engine for all of them. That allows you to keep at least the base configuration up and running. Now, when it gets into policies, that's where you get more creative. I am a fan of not really GitOps. I'm not a huge fan of GitOps in general because, one, generally when GitHub Enterprise or GitHub is used for projects, anybody in the company can see that, which means anybody in the company can see what code is put in there because they want people to be able to do PRs and do inner sourcing. So a lot of those different policies may be viewed with people who should not be seeing them. The other thing with GitOps that I tend to not like is you can't make it easy for developers or people who don't know gateways to be able to consume or at least publish their APIs to your gateways, or request APIs do get published. You're making them do a bit more work than they really should. One of the examples is a lot of the CI/CD management for like Apigee is fill out this massive XML, but we'll run a Maven job to push it up to the gateways. Well, if I'm a developer and I'm filling out all this XML for you and basically doing the job, why am I not running my own gateway? So that's where GitOps and me don't really see eye to eye. I would say build a command center, build a tool that allows you to manage it based on your scenario. I would say the more that you can abstract how policies work and make them identical in the functionality side, language-wise and what you put into Azure APIM versus Apigee is going to be different. But when you say, here's my JWT policy, it functions the same across all of them. Even if you have to implement it slightly different, the end result, the inputs in and the outputs are identical. Because then you don't get confused on the context, you don't get confused on managing this node versus that node. As for actually pushing out the policies, I'm going to go back to build a policy engine if you have that complexity, and really figure out what's right for your team at the time. It will be hairy at first, it'll be a lot of work at first, but once you get it, and you're able to do push button deploys with policies across a CDN provider, multiple different gateways, and it just works in seconds, that's when you realize that your team is well versed in the gateway space. But yeah, and then if you pick up services like Kong or Zuplo or enterprise services, they usually have a tool that does it for you at that level. But again, you're back to one gateway, so it's a little bit easier anyways. So, questions? So the question I have for you all is without giving too much internal data, how many gateways do your companies that you're working for or deal with actually run, or what's their segmentation policy? Yes.
I think 4.
4 gateways? Is it environment based? Is it?
Well, and each one has a non-product version.
Okay, so you do it based on
So-
business?
Based on when it was determined that you needed one, did you know there already was one, or did you have anyone who could do it for
So
you?
the classic shadow IT, we just stood one up because we needed one.
So we're at the point where we're improving things. We have a couple of SMEs, but no one's really out here. Ownership's unclear. Some are shared.
Okay.
Some are critical, but the developers don't even realize that they got one because it was stood up for other businesses who needed exposing APIs.
Oh, interesting.
And others are just some are very well aware and regularly managed. half of them are in Terraform, half of them are gonna be Terraform, gonna be converted. But we're trying to decide, should we have, is it gonna be centrally managed like a cloud or like security or whatever? Do we want, how much responsibility do we want the dev teams, the backend teams, the customer facing teams, integration teams? Who's gonna do what? So we're trying to define roles and how much is central and not.
My biggest suggestion on that is if you're not dealing with regulatory data like HIPAA or PCI, where you have to have different qualifications to view that data, if it's all equal data playing field from regulatory side, get one central team. And either that central team nominates advocates or champions in other groups that they're dotted line to that central team. Get that central team because they need to be the most in depth on the attack vectors, the most in depth, and educate people on it. I would, as much as I would love every developer to know everything up and down the stack and know what they're doing across the board, you're not going to get that. Try to make it easy for them to understand the big principles around APIs and what they need to secure on, what they need to do in their apps, like verify tokens on every level, right? Don't assume a token's valid, verify it every time. Verify multiple pieces in the token, not just that it's a good signature, because that's a security flaw. In fact, a lot of people got hit by the Microsoft bug because you could take an Azure AD, you could log in. If I created malicious Azure AD and I typed in your email address into my AD and then I minted a token, most services weren't validating the tenant ID that token came from or the audience that token was for. But now it could look like you as a person going into your systems. So when you verify tokens, as the developer should be doing, verify multiple parts of the token. Ensure the audience is there, make sure it's not expired, make sure it's not from the future, things like that. But that should be where they should have to be concerned about routing and everything else is, here's my endpoint, this is what you told me that people can access me on, and I'm doing a bare minimum JWT policy. I should be doing more security, but that really depends on what they're dealing with from data authorization wise, but bare minimum JWT validation for your token. Let the gateway do a lot more of that granular, protections or some of those areas to where you may not want to expose them to. Now, that being said, there's always the caveat, if you have a team that's really a bunch of rock stars and they're ahead of the game, start letting them in on the operations of how it works, because they might have insights of how to manage it better or how they can improve the flow so other people understand more. So leverage those people who are above the curve and get them to really help you evangelize and educate how the gateway works in the attack vectors. But I would ultimately reduce as best you can to a centralized team, because they're going to spend their blood, sweat, and tears learning the attack vectors. I mean, I learned so much running a gateway at a large retailer that it was impressive what I did not know when I started it. And then when I left it going, oh, I don't like the internet. It's scary out there. So, yeah. The key thing I will say is segmentation. At the start of it, people will think, oh, it's too many hops. It's, you're adding availability issues. The more gateways you have, we don't need to do a gateway in our internal traffic. You do. Security posture-wise, you really should. Internal attackers, as I mentioned. But ultimately, the way I view it is if you've solved every problem in computing and building a service, that the overhead of one gateway to communicate with your service or the extra hops in the way is your bottleneck, congrats, you've solved a crap ton of problems. Take out those extra gateways because you probably don't need them at that point. But realistically, people don't build optimized services for many, many years of working on them, or they keep building new services that are not optimized. That's not the bottleneck. That's the biggest squeeze. If you look in the cloud and you run a gateway to a service or a gateway to a gateway to a service, you're adding 10 milliseconds of overhead. If that's your bottleneck, I'm impressed. Take them away.
You're chaining gateways that you can get into a configuration nightmare.
You can. That's why you make sure you do segmentation. When you do the chaining of gateways, you make sure they have purposes, right? If you're doing one from like the regional one, it only cares that this service exists here. I'm going to point to it. I'm not going to do the extra schema validations. I'm not going to do, and that also goes to like 2 sessions ago or 3 sessions ago, I gave a whole thing about API gateways. And I griped about the fact that people have turned them into enterprise service buses with all the functionality that they're trying to shove into them. You really don't need to do that much in the gateways. It's not, schema validation is one that a lot of people are pushing for, and I'm like, why? That's an app concern, not a gateway concern. I'm not going to bloat my gateway with gigabytes of schemas that I have to understand. Let me route it to the service, and the service can handle that. But I can look for Log4j and SQL injection and common patterns, because that's minimal configuration, minimal bloat.
What we used to do is used to do a TCP layer 4 gateway that points to layer 7 gateway. So that layer 4 gateway, you get that segmentation, but there's no configuration. It's just a point to a port and just go. So
Yep.
you get that segmentation really.
So yeah, and there's tactics like that as well, to where you can leverage different layers of the HTTP stack for your gateways. Like global load balancers can be functional as a segmenter, because you can route them to be very specific on, hey, this type of traffic comes in, I'm routing it only this way. So, any other questions? I don't know how we are on time.
7:17.
Sweet, came in under. There is my email address. I don't really care if it's on the internet now, because it's been there for too long anyways. If you do have any questions, or you want to chat about APIs, gateways, programming, yell at me, whatever, I don't care. There it is.
Will we have will we be able to post the deck?
What?
The deck?
Oh yeah,